Hey friends, once again we are in the discussion of partial differential equation. So we are given a problem that verify that the function phi xyz equivalent to 1 out of square root of x squared plus y squared plus z squared satisfies the Laplace equation del 2 phi by del x squared plus del 2 phi by del y squared plus del 2 phi by del z squared is equal to 0. This is the Laplace equation that is of 3 dimensions. So now what we are going to do is to right away begin and see. So if we have been told, if it is now told to us that phi x y z is equal to 1 out of square root of x squared plus y squared plus z squared. Now, if it is to satisfy this equation, then that means we are going to get a partial differentiation of phi with respect to x, with respect to y, with respect to z. Then we again partially differentiate those first partial derivatives to get the second partial derivatives of phi with respect to x, y, and z. So let's begin. What is their phi by their x? So remember, we are going to have this function equivalent to x squared. For simplicity, we can make it x squared plus y squared plus z squared at power negative a half. It still remains the same. So if I partially differentiate here, that means I'm going to keep y squared and the z squared constants, and I differentiate x squared. So what does that mean? I'm going to have 2x. If I differentiate inside what is inside, I'll have 2x, okay? I will have 2x, okay? Then I differentiate the whole of this, and this would become negative a half, okay? Negative a half x squared plus y squared plus z squared. Obviously, if I reduce this by 1, then I'm going to have negative 3, okay, negative 3 out of 2. So that's 1. Let's proceed and take the second derivative of now this partial derivative. So del, okay, by del x of del phi del x, this is going to be del 2 phi by del x squared, and this is going to be, I differentiate this again, and we are going to be using the product rule. So if I do that differentiation, this is what I'm going to have. Remember, this was negative 2x out of 2 into x squared plus y squared plus z squared at power negative 3 out of 2. So this and that will go away. So now let's go ahead and do the differentiation. So if we differentiate this, what is it going to be? Remember, you can say this is a u, this is a v. So you say u dv, okay, dx plus v du dx. So this is going to be, if I differentiate this, okay, I will have u dv, so that I have negative x times dv. So if I differentiate this with respect to x, I will have again 2x, okay, and x squared plus y squared plus z squared. Then I subtract, or I reduce this by 1, and this is going to be negative 5 out of 2, okay? Then I add, so I add then du, so this is going to be negative 1, okay? Then times what? Times v, which is x squared plus y squared plus z squared power negative 3 out of 2. Yes. So meaning del 2 phi del x squared is going to be, if I reorganize this, If I reorganize this, remember I had a negative somewhere here because when I differentiated what is inside here, I got also times negative 3 out of 2. So I will have negative 2x squared times 3, and this is going to be positive, divided by 2. Yes. Then times x squared plus y squared plus z squared, okay, at power negative 5 out of 2. And then I'm adding x squared plus y squared plus z squared power negative 3 out of 2. Now I can take it back to the original fraction so that I have, this is going to be, remember this and that will go away, so I'll have 3x squared now divided by x squared plus y squared plus z squared, then power, this is now going to be 5 out of 2. Then remember I had a negative 1 here, so I had a negative 1 here, so I will have negative, then 1 divided by x squared plus y squared plus z squared, okay, power 3 out of 2. So that is del 2 phi del x squared. So this is the LCM, so I will take x squared plus 5, plus y squared plus z squared, power 5 out of 2. And if I divide it by 1 here, if I divide it, I divide it by this, I'll have 1, so that I have 3x squared. Then minus this divided by this, I'll have x squared plus y squared plus z squared. Yes. So this is going to be del 2 phi by del x squared, and this is going to be that. So finally, let me rewrite it properly. Del 2 phi del x squared will equal 3x. Yes, 3x squared minus x squared plus y squared plus z squared, and everything divided by x squared plus y squared plus z squared power 5 out of 2. So that is one. Now we do the same for partial derivative of phi with respect to y. So if we do the same for phi with respect to what? With respect to y and z, we will get similar functions. So del 2 phi by del y squared will therefore equal 3y squared minus x squared plus y squared plus z squared, and we are dividing everything by x squared plus y squared plus z squared, everything power 5 out of 2. Similarly for z, this is going to be del 2 phi with by del z squared will be 3z squared minus x squared plus y squared plus z squared, okay? Everything again divided by x squared plus y squared plus z squared to power 5 out of 2. So what I'm going to do, for me to verify that this is equal to 0, I'm going to just add my partial derivatives. Therefore, 3x squared minus x squared plus y squared plus z squared, then everything divided by x squared plus y squared plus z squared to power 5 out of 2. I'm going to add 3y squared minus x squared plus y squared plus z squared, everything divided by x squared plus y squared plus z squared to power 5 out of 2. Then I'm going to add there again 3z squared minus x squared plus y squared plus z squared divided by x squared plus y squared plus z squared, everything again power 5 out of 2. So what does this give us? Okay, what does this give us? Obviously, we are saying this is the same as del 2 phi del x squared plus del 2 phi del y squared plus del 2 phi by del z squared. Yes, so we correct like terms. You will see that everything is out of x squared plus y squared plus z squared power 5 out of 2. So I'm going to put that down so that I have, you will have x squared plus y squared plus z squared to power 5 out of 2. So if I'm adding, I'll have 3x squared plus y squared plus z squared first. So I'll have 3x squared plus 3y squared plus 3z squared, and then we shall take away 3 into x squared plus y squared plus z squared. So if I open brackets, I'll find this is the same and this is equal to 0. Therefore, since this one itself is the same as del 2 phi by this, okay, you continue, then therefore, or hence, del 2 phi del x squared plus del 2 phi by del y squared plus del 2 phi by del z squared is equal to 0, and it has been proven. So this is how you can deal with such a problem, and while talking about partial differentiation or partial differential equations.